What are Kirkwood gaps in the asteroid belt? Imagine walking through a crowded hallway where certain spots are mysteriously empty. In space, the asteroid belt has similar empty zones called Kirkwood gaps. These gaps are regions between the orbits of Mars and Jupiter where fewer asteroids are found. They were first noticed in the 1860s by Daniel Kirkwood, an American astronomer and mathematician. He saw that the distribution of asteroids was not even. Instead, there were clear zones with very few or no asteroids at all. The reason for these gaps comes down to the powerful gravity of Jupiter, the biggest planet in our solar system. When an asteroid's orbit lines up in a special way with Jupiter, it enters what is called an orbital resonance. This means the asteroid completes a certain number of orbits around the Sun in the same time Jupiter does. For example, an asteroid in a 2-to-1 resonance orbits the Sun twice for every one orbit of Jupiter. These resonances happen at specific distances from the Sun, and they are where the gaps form. Jupiter's gravity pulls on asteroids in these resonant orbits repeatedly. Over time, these pulls can change the asteroid's path or even fling it out of the belt altogether. This process clears out the space at these resonant points, creating the Kirkwood gaps. The most noticeable gaps occur at ratios like 2-to-1, 3-to-1, 5-to-2, and 7-to-3. These ratios are simple fractions, which means the gravitational effects are strongest there. Understanding these gaps helps scientists predict how stable the asteroid belt is over long periods. It also helps track asteroids that could come close to Earth. Some asteroids near these gaps can have their orbits shifted enough to become near-Earth objects. Monitoring these regions is important for planetary defense and safety. For politicians and space agencies, Kirkwood gaps show how the gravity of a large planet like Jupiter can shape the entire asteroid belt. They reminded us that space is governed by predictable laws, and that studying these laws helps us protect our planet. These gaps are more than just empty spaces. They are clues to the dynamic forces at work in our solar system. They also highlight why ongoing space observation and research are so important for understanding potential asteroid threats and ensuring Earth's safety. In everyday terms, Kirkwood gaps show that even in space, small forces like gravity can have big effects over time. They teach us that paying attention to these natural patterns can help us prepare for future challenges. Whether it's scientists tracking space rocks or leaders making decisions about space safety, these gaps are a clear example of how understanding the universe can benefit us all.